Okay, now in terms of processes, first thing we have to find the agent. So the first step is to find the agent. You have to find the home agent and the foreign agents. So they advertise and they also respond to solicitations. So there are messages in mobile IP which says mobile IP advertisement or agent advertisement. There are query messages which are solicitation. So mobile can send a solicitation to mobile agent using a multicast group. Because we don't know the address, we just send it. Is there anybody who knows mobile IP? And that address is 224.0.0.11. That's a multicast IP address. Anybody knows how the multicast IP addresses are different from the unicast IP addresses? Okay, so basically IP address has two parts, the host part and the network part, right? In the host part, you could have a multicast that will be multicast into the local network, subnet, right? In the network part also you could have multicast where it will be multicast over the world. So this one is basically a subnet multicast. It doesn't go all over the world, because when you ask this query, if there is some network, if there is somebody on the local network, it will respond, not somebody from some other place. Mobile agent selection. So you might get more than one response, in which case you can select an agent and then say, okay, what is the number now people can reach me, which means what is your new IP address, or or the mobile agent's IP address. That's a new care of address. Then it goes back to its home, calls the home agent. Home agent sends a reply to care of address, and then the mobility binding takes place. That is basically the register. Now, every registration is only for a limited time. So you say, well, I'll be here for 3 days. In that case, you are there for 3 days. After 3 days, the home agent will forget you and will not know where you are, unless you register from some other place or from the same place again. So basically, there is no need for a deregister message, which doesn't say, well, now you forget my address. But so basically, you have to re-register within the lifetime. One easy way to deregister would be that you could say, well, I am here and I will be here for 0 seconds, or I will be here for another millisecond, and then you're done. Then you will be deregistered, right? After that. Oh. When you come back to home, then you deregister with the home agent, and you can set the care of address to your permanent IP address, and set the lifetime to 0, which means I'm here forever. Deregistration with foreign agent is not required. It expires automatically. And the simultaneous registration with more than one COA is also allowed. So you could be registered with more than one foreign agents for handoff purposes. When you want to move from one place to the next place, your calls are coming at the old hotel as well as at the new hotel. So we already talked about tunneling, but a little bit more discussion here. So the correspondent sends packet to the home agent. Home agent has a tunnel to the care of address. From there it goes to the mobile host, where the care of address could be inside the mobile host. Alright, that could be foreign address. What tunnel means is encapsulation. What encapsulation means is that you just take the old IP packet, full IP packet, including the header, etc., and put it inside another IP packet with new headers. Okay, and this is what is sent to the mobile host. The mobile host opens this up. Actually, it goes to the care of address. Care of address opens up this packet, and here in this header it says, well, this is a mobile IP packet, so it knows that this is not for itself, this is for somebody else. Then it opens it up, reads this header, and then finds out who it is for. It has a registration for that, and then it gives it to that. Yeah, right. So now either this packet could be encrypted itself, in which case the correspondent sent it encrypted, right? Or the home agent could encrypt in this header, in which case it will have to negotiate with the care of address some keys, and then this header will be encrypted, right? So either the correspondent has negotiated the keys with the mobile host, which would be the better way, I suppose, the end-to-end security, that we don't have to trust the home agent or the care of address. Or if that is not the case, then basically the home agent and the care of address could do it. But the tunnel actually does not require security. There are insecure tunnels. Okay, so security is an option. But tunnels are always used whenever there are something in the headers that are not understood by the routers on the path or routers on the path. So then you just put a new header which is understood by everybody along the path, and then the new header is not visible until it reaches the end of the tunnel, at which point you start using the old header. So everybody understands what is a tunnel, right? Tunnel is basically another name for encapsulation packet, which means that you're putting the old envelope inside and a new envelope. So you have two envelopes. Now reverse tunneling. So if this is the correspondent node, it sends the packet to the home agent sends it to the mobile node. Now the mobile node has to answer back to the correspondent. It has two choices. It could send its packet back to the home agent, and the home agent could send it to the correspondent, which is a long way, or it could send it directly to the correspondent. Now the problem with this path is that there might be some gateways, firewalls, filters in the foreign network that will look at all the IP addresses and say, wait a minute, this is not our node. This is not our IP address. If this one sends it with the old IP address, home IP address, then that will be rejected, right? So basically, the solution is, this one always works, is that you always send the packet with the foreign. Now here this will have a foreign address as the source, and then it will go to the home agent. Home agent will take out the outer envelope and then send with the home address as the source to the correspondent. Right, Sakit? What is the reverse? What are the addresses in the reverse tunnel? Yeah, what are the addresses? So there are two parts of the reverse tunnel. There is this part here. What is the source address and the destination address? Mobile node has two addresses: foreign address and a home address. What would be the source address of the packets here on the outer envelope? On the outer envelope, it will be foreign address source. In the inner envelope, the source would be home address, right? So what will happen is that packet will be opened here, and the outer envelope will be discarded, and then it will go on this part, and this part, the source address would be the home address, right? And the destination address would be the correspondent nodes. What would be the destination address here? Home agent's address, which is different than home address. Remember, home agent has its own IP address. Now, what happens if the home networks have dynamic IP address? You know what is the dynamic IP address? That your address is not permanent. I mean, every time you come to your office here in WashU, you get a new IP address, right? So DHCP-based hosts do not have initial IP address, so DNS address on the home network. So basically, everybody has their own solution, and Cisco solution is that they send a request to the home agent, and the home agent does the DHCP request on behalf of the foreign network and says, okay, now your virtual IP address is such and such. I mean, you're really not here, but I made a request to the DHCP server and got this address reserved for you. So whenever somebody sends to that address, that becomes your IP address. And so this is how it works. The mobile sends a request to foreign agent, which is a registration request, and it is addressed to home agent 1. Oh, actually, this is a different problem. This is not the problem of dynamic addresses. This is the problem of dynamic home agent assignment. What that means is that your home agent has to change. Okay, dynamic means time-changing home agent. So basically, you are with the home agent 1. You send a registration request to home agent 1, and it says, sorry, I am not doing that service anymore for you. I mean, your assistant has changed. So it says redirect to home agent 2. Now you have a new assistant. It comes back here, and then it says, oh, my assistant, please remember that I'm in hotel number this. So it registers with the new home agent. So the home agents can change, can move. And the question is, if the home address has gone down, how will this happen? That can happen again by what? Can you think of some way of that happening? If the previous home agent is down, how can somebody say that, redirect to home agent 2? It's the same thing as you did before, not timeout. If the address is ARP, home agent 2 could send that ARP and get all those things and say, okay, now please send this is your new address, new IP address for your agent. Or somebody else could do it too. I mean, if this home agent 2 was in some other network, anybody here on this network could become home agent 1 and send that. It doesn't know much about other things, but at least it can send the redirect. That if suppose the home agent is on a different network, the packets will not even get there, because the correspondents don't know this different network. If you wanted to do multi-hop thing, where you go to one agent and that sends to the second agent, that sends it to chain. But that would be kind of waste of resources, because you're putting packets and enveloping them. You could as well just go to the this one. But on the same network, this is possible though, right? Okay, on the same network, it is possible. All right, now we are talking about changing the attachment point. So this is called network mobility, and there is a special IETF group called NEMO. NEMO stands for NEMO, network mobility. And the idea here is that the whole network is moving. So here is the correspondent. It sends a packet to mobile router's home agent. So here you think about, let's say airline. So I want to talk to somebody who is on airline flight number 1523, American airline flight number 1523. And so we just send it to American airline network, and that router has now gone. The flight is now connected in Minneapolis rather than in St. Louis. So that mobile router has a home agent, and so all the packets for that network are captured here at the head office and sent to Minneapolis and delivered to that router in the plane, and then from that it is easy. This node doesn't even really have to worry about anything. All the registration is done by the mobile router, right? This agent does have to tell its correspondent that I'm on an airline flight number 1523, otherwise they will never ever go to American Airlines, this one. So the interesting point is, if this was surfing a web, so it will just send a request and it will have its airline address, and then the web server will send the responses, and then from Minneapolis he has moved to some other city, the responses will go to the right places still. Okay, so there are, node is not the plane. Node is a passenger inside a plane.
Yeah, I mean, the plane, right?
In the plane, this is the plane router. This is the router in the plane. This is one thing. It is called fixed because it is not moved.
It's moved, right? I mean, it's on the plane.
See, it's like this. When you're inside a car, are you moving or are you sitting? You're sitting. Either interpretation. You could be saying I'm running, but you're really not doing anything. Probably sleeping. So that's the thing. That is fixed with respect to its connection. Alright, this is all described in RFC 3963, which was done in January 2005. And mobile networks may have visiting. Now here, this is recursive stuff. So you could have some mobility inside the plane. So mobile network may have visiting mobile routers or visiting mobile nodes. So there could be some people who will be coming in and out of the plane, which plane doesn't make sense, but it could be a train, in which case it makes sense. There could be some new network coming in or new people coming in into the network and getting out. some they probably do with the plane too, but right now you just can't jump off. So, so all those kinds of mobility has to be considered. Security issues. So there are several trust things here. First is mobile node to foreign agent. You may or may not trust them, right? Foreign agent to home agent and the mobile agent to home agent. There are three parties, so we have all the three-way communications. And so basically, I don't know whether let's see how much we can cover in this here, because I don't want to get into security right now in this course. But those of you who know security probably will understand this keyed MD5. That's the message digest number 5. So that is basically what is used for message authentication, to make sure that the same message that was sent from the sender was received by the receiver. Nobody else modified it along the way. Then there is key management. So somebody has to give you the keys. Confidentiality. So there has to be some encryption, and they use IPsec for that. ESP is an IPsec header. It is called encapsulating security protocol. So basically, this is the protocol for encryption. Replay protection is there, so that if somebody got your packets and played again the same packets, these are all the standard security things that we do anyway. But here in the case of IP, mobile IP, we just want to make sure that all the players have whatever level of security they need. Location privacy. So actually, you don't want your correspondents to know where you are. So that is also allowed, because basically they will never know your foreign address. Ingress filtering. Firewall drops outgoing packets with topologically incorrect source address. So basically, that's another thing, is that you couldn't really use a wrong IP address if the network was secure. So if it was a secure foreign network, they will not let anybody foreigner to use their address, that as a home address, and to send out packets like that. So all that can be done. So that can be taken care of by reverse tunneling. Okay. All right. Now VPN. So if you have a VPN gateway, generally the way we do VPN is that if you say, for example, I don't know how many of you have used VPN from your home to a WashU, but WashU has a VPN, right? When you are at home, you can still print on your WashU printer. How you do that? By connecting to the VPN, and then you get an address which is inside WashU, and you can use all the resources, including access to things like IEEE website, which is only allowed, for IP address. For ACM and IEEE, in fact, there might be a proxy node that you log into first, and from there you can go on to anywhere in the world because you are logged into that one. So that is possible, but basically, so the idea is, generally what happens is when you are a mobile node and you go somewhere else, you cannot connect directly to the home agent. You have to connect to the VPN gateway, right? And so when you connect to the VPN gateway, that connects to the home agent. So you have a two-step process. First of all, you need a IPsec tunnel between yourself and the VPN gateway. And then basically the home gateway has to talk to the home agent. So there are 5 possible locations. So the question is, where do we put home agent? One possibility is that the home agent could be anywhere inside. Another thing could be the home agent could be part of the VPN gateway. So home agent could be inside the VPN gateway, which could be at the boundary or could be inside the network. And then Another possibility is that the home agent could be outside the network, and so on and so forth. There are many, many possibilities where the home agent is, and the solution is different for each of these locations of home agent. So right now, basically at this one only lists possibility location, and this is still working. They are working on as to how to modify it. The problem with the IPsec is that if something is like this one is IPsec here, the foreign agent cannot read any addresses inside. I mean, foreign agent has only access to the IPsec header, but not any inside header. So IPsec itself is an encapsulation, which itself is a tunnel. So you take your original packet, encrypt it, and put it inside another packet which has only 2 addresses. So there are several fields which are not available, and nobody can decrypt it. So nobody can open the envelope. That causes some difficulty. And then there are other trust issues. While you trust your VPN gateway, you may not want to see. You might have another envelope inside that, so that the home agent can read your real traffic, and so on. So let's see. First one case where foreign agent, home agent is inside the intranet. So here is the home agent, here is the router, here is the VPN gateway, here is the foreign agent. If this is the case, then basically foreign agent cannot get the packets from outside. Basically all the packets have to be at the mobile node, and the mobile node sets up a tunnel with the VPN gateway, and then they just pass through the foreign agent. So basically the home agent sends it to the router, which sends it to the, this is a local router, which sends it to the VPN gateway, and VPN gateway has an IPsec tunnel with the mobile node, and so all the packets go to the mobile node, and foreign agent basically is not the care of address. This is the most common configuration, and basically the old mobile IPv4 before this will require changes to do this. Okay, let's see some other configuration. The fifth configuration is where the VPN gateway and the home agent are in the intranet, are in the same box. If they are in the home agent inside and they are in the same box, then this works without problem, because foreign agent can set up with the home agent and a tunnel, and then there could be packet encapsulated all the way to the node. So basically all the packets that are going to the mobile node, they are encapsulated in the blue format, and then the blue envelope is opened by the foreign agent, and then the mobile node gets the correct address. So this is basically easiest way to do it, but it is not scalable to thousands of mobile users, because all the users have to somehow talk to the. So there are the other 4 combinations we have clearly not presented here, because this one is the most common one and requires changes, and this one is doesn't require any changes, but it is not that common one. So those are the 2 extremes, and there are 3 other solutions which are in between. So anyway, this brings us to this end of this mobile IP, this part of the mobile IP, and the 5 key points are that mobile node gets a packet via the tunnel from the home agent to the care of address. So there is a tunnel which starts from the home agent and ends at the care of address. The reverse tunnel is from the mobile to the home agent, is optional, and it is required if the foreign network does not allow these foreign addresses, IP addresses as source, if they have a source address checking. It is possible to dynamically assign the home address and home agents. So that was the Cisco solution we talked about. And then the network can move. So the network mobility is supported, which requires reverse tunneling. And then VPN solution is still, we need to think about more. And for proper nesting of the IPsec tunnel and the mobile IP tunnel, because there is a mobile IP tunnel and there is IPsec tunnel, and so we have to see which goes inside, which goes outside. All right, now reading assignment. So there are tons of RFCs and mobile IP, as you will see in the next few slides. I want you to read at least these 5 or 6 RFCs, and these are what are the topics that we have already covered in the class here. So this one talks about general, mobile IP thing. There is something called terminology. I forget which one it is, but there is one which has all the terminology about those handovers and things like that we talked about. That was an interesting one. And then this is about fast handovers and VPN gateways. In addition to these 6 RFCs, then there are 20, 30 other RFCs that you don't have to read for this course, but have to be aware of. The work is still going on. As you can see, there is an RFC which just came out this month as to how to do session description over the mobile IP and all that. So the work is going on, but if you were ever working for a company on mobile IP, then you know what to look for. So there is a paper which was written just like this in the last wireless class on mobile IP, which is also a good survey paper, basically if you want to get started. Now there is, in addition to mobile IP, there are other IP issues that we actually don't think that we are going to discuss. We may not have time. But IP layer issues, there are 4 other groups that are working on wireless related issues. One of them is called MANET, Mobile Ad Hoc Network. So they talk about ad hoc, whereas ad hoc is opposite of infrastructure, so there is no base station. And so those groups are developing routing for ad hoc networks. Then there is IPv6 over low power personal area networks, called 6LoWPAN. Then there is a routing over low power and lossy networks, ROLL, and then OSPF wireless design. This is not an IETF group, but there is if it is not a group, I don't know how it is associated with IETF, but it is with the IETF. So it is an IETF website, OSPF wireless design team.